the types of solar eclipse. Okay, so again, I'm going to draw, the sun really, really big. And I'm going to draw the Earth right here. I'm going to push it back a little bit. Here's the Earth. But now I'm going to draw the moon in the picture. And it turns out that the moon, like we said, has a much smaller shadow, but it has the same parts to it. So right behind the moon, you have the darkest part of its shadow, which is the umbra. Okay. And around that, you have the penumbra. I'm just going to write a P for penumbra. So that means, check this out, in the lunar eclipse, the whole moon can fit inside of one part of the Earth's shadow, okay? But the Earth doesn't fit in the moon's shadow. And that's going to be different. Check this out. That means that if this was what was happening on one given day, if you're standing in here, you can see an eclipse. But the people that are standing right here, they won't get an eclipse. So when a solar eclipse happens, you have to be standing in the right place in order to see it. So not everybody gets to see that eclipse. Whereas for a lunar eclipse, everybody on the whole backside of the Earth gets to see a lunar eclipse when it happens. That's another reason that it's a lot easier to see a lunar eclipse. And in fact, if you stand in one part of the shadow, you'll see one kind of eclipse. And if you stand in a different part of the shadow, you see a different kind of eclipse. So some people are asking what you could see in Florida a couple of years ago. Let me get to that in 1 second. I'll address that in just a second. So here we go. Actually, here you go. Here's where we were in Florida last time we were having an eclipse. And let's call this location 1. If you were standing right here, right there, that's roughly where Florida was during the last solar eclipse. We were right here in the penumbra, okay? Now check it out. If you're standing here in the penumbra, if you look straight up, you can see part of the sun, but the moon is blocking your view of another part of the sun. So that means if you're standing in the penumbra, only part of the sun will be blocked. And so we'll call it a partial solar eclipse. And that's what we saw in Florida during the last solar eclipse. Was the entire sun blocked out? No, only part of it. It looked like the sun had a bite taken out of it, and it got a little bit darker because some of the sunlight was being blocked. Okay, so a partial solar eclipse is going to have part of the sun blocked out, and as that solar eclipse is happening, you can see that bite move across the sun. However, that's not what everybody saw, right? It's not what everyone saw. It got pretty dark, right? It got like evening level of darkness, yeah. But if you were up in, say, North Carolina, roughly around there, you would have been standing directly in the umbra during that solar eclipse. So let's put location 2 is in the umbra, okay? And if you're standing in the umbra, how much of the sun is going to get blocked? If you're standing in the umbra, how much of the sun gets blocked? All of it, yes. So we're going to call that a total solar eclipse. Okay? So a total solar eclipse is what you see if you're standing in the umbra. So that means that two people at the same exact time could see two different kinds of eclipses if they were standing in different parts of this shadow. Okay? And if all of the sun is blocked, that means it's going to get a lot darker outside. So people in North Carolina, it basically looked like night when the solar eclipse was happening, when the sun went full, totally blocked. However, that doesn't mean that the sun just disappears, okay? You probably saw pictures of this, but let me get the picture from your book back. So here, right there, that's what we saw in Florida. It was a partially blocked sun, right? But if you look up there at the very top, that's what the sun looks like during a total solar eclipse. Suddenly, this big hazy cloud appears around the sun when the sun gets completely blocked out. And you can actually see here's a set of pictures taken during a total solar eclipse, and you can see the bite get bigger and bigger and bigger and bigger, and then as soon as it completely blocks the sun, poof, you see this big cloud of gas right there, okay? And then it disappears when it goes back out again. Here's another picture, the same thing. This is a total solar eclipse. Now, does the sun know that it's being blocked? No. So it's not like the sun just shoots out this stuff when the eclipse happens, right? It's not a weird effect like that. So what is happening? Okay, what is happening in this situation? Well, first of all, there's a name for this. There's a name for this stuff right here. It's called the corona. Okay, it's called the corona, which unfortunate name right now. It is the corona, just like, you know, the thing. Why do we call it the corona? Why would we call this the corona? Does anybody know what corona means? It's been in the news recently, so they've been talking about this. Yeah, it means crown. It means crown. So in Latin-based languages, there's usually a word like that means crown. So hundreds and hundreds of years ago, people said, hey, that sort of looks like the sun, like we're looking down on the top of the sun's head, and this is like a crown around its head, right? Sorta, I guess. This sorta kinda looks, whatever. That's just a part of the sun. That's just a part of the sun that is always there, right? So why is it that we can only see it when the sun gets blocked? Why is it that we can only see the corona if it's there all the time? Why can we only see it when this happens? It's kind of related to something we just talked about. Yeah, the moon is basically helping us. So, don't look at the sun. Don't look at the sun. But if you do look at the sun, what does the sun look like? When you look at the sun, why don't you want to look at the sun? Why would it make you go blind, right? Why would it make you go blind? Why is the sun not a good idea to look at? It's very, well, here you go. Don't overthink this. It's because it's too bright, right? The sun is too bright. So the main part of the sun, the part of the sun that's being blocked by the moon right here, is so bright that your eyes can't adjust to it, and it makes it so that this dimmer part of the sun doesn't normally, you can't see it. It's too dim compared to this part of the sun, right? So it's just the same as not being able to see the red light on a partial lunar eclipse. That corona is too dim compared to the rest of the sun for your eyes to normally see it. But when this part gets blocked out, now you can see the corona. Now, don't get me wrong though. If there's another solar eclipse happening and you go to see the total solar eclipse, should you look at the corona? Should you look at this? Should you look at this during that total solar eclipse? A lot of good jokes happening down there. Is it a good idea to look at that corona? No. A lot of people get the wrong idea when people say that the corona is dimmer than the sun. The sun is really bright, right? So that means the corona, even though it's dimmer than the rest of the sun, is still really bright. If you look at the corona, you can go blind in less than a second. Or even if you don't go completely blind, you could have a fuzzy blind spot in the direct middle of your vision if it doesn't wipe out the whole thing. So no matter where you look, you'd always see a blind spot directly in front of you. So you don't want to look at that. Now somebody said, my teacher told me to look at the sun today. I did not tell you to look at the sun. Do not look at the sun. It's a bad idea. Don't sue me when you go blind. Don't sue the school. I told you not to look at the sun. So we're not liable for that. Okay? Do not look at the sun. Now, all right. One last type of eclipse. One last type of eclipse. Here we go. To see the last type of eclipse, where do you want to stand? Okay? Turns out to see the last type of solar eclipse, you're going to stand in the exact same place as the total solar eclipse. So I'm just going to put a 3 right here also. Which is a little bit confusing. So the same place, if you're standing directly behind the moon, you're either going to see a total solar eclipse or you're going to see an annular solar eclipse. Annular. Okay. Now, what is this? What's an annular solar eclipse? First of all, this is not the word annual, okay? It's not annual, okay? It's annular, okay? Does anybody happen to know what this part of the word means at all? Not a lot of people do. Hold that thought for a second. It's going to make sense in a second. Hold that thought. Here we go. Now, here's my question. What shape is our orbit around the sun? What shape is the Earth's orbit around the sun? It's not a circle. What shape is it? Kepler figured it out. It's an ellipse, right? It's an oval shape. The orbit of the Earth is an ellipse. So is the sun always the same distance away from us? Is the sun always the exact same distance away from us? No. Right? Because we're moving around an oval, the sun is not always the same distance away from us, okay? Now, that's also true for the moon. The moon's orbit around us is also an ellipse, and so sometimes it's further away and sometimes it's closer, okay? Now, let's say that you're perfectly lined up behind the moon, getting ready for a total solar eclipse. But let's say on that particular day, we happen to be a little bit closer to the sun than usual. If we're a little bit closer to the sun than usual, what would that do to the sun in the sky? If we're closer to the sun than usual, what's going to happen to the size of the sun in the sky? What's going to happen? It'll be a little bit bigger, right? The sun will be a little bit bigger in the sky. So let's say we're ready for a total solar eclipse, but because we're a little bit closer to the sun than usual, the sun is going to look bigger. And let's say on that exact same day, we happen to be a little bit further away from the moon than usual. In that case, the moon would look a little bit smaller than usual, okay? Now, in a total solar eclipse, the moon perfectly covers the sun. But if on this day the sun was bigger than usual and the moon was smaller than usual, what's going to happen? If the moon is too small, it won't completely cover the sun. And if that happens, then the bright part of the sun will stay visible, okay? And if the bright part of the sun stays visible, what will you not be able to see for that eclipse? If you don't get the entire bright part of the sun covered by the moon, what part won't you get to see? What will you not get to see in that situation that you would get to see during the regular total solar eclipse? Yeah, the corona. The corona would not, so you wouldn't see that's true, you wouldn't see the very center of the sun, but you also wouldn't get to see the corona, because the corona only is visible if you completely block the rest of the sun. And in this case, instead of getting a total solar eclipse, you're going to get this. So here, the moon is just not quite big enough to cover the full sun because the distances are different. And yeah, we can't see the center, but notice no corona. And that's because this little part of the moon, of the sun, this little edge of the sun is bright enough to blind your eyes to the corona, okay? So the corona's here, you just can't see it. And this is your annular solar eclipse, okay? And so what does annual mean? It actually means ring, okay? So this word right here is just the ring-shaped solar eclipse. So can you never look at the sun? Pretty much never look at the sun. The only time that it's somewhat safe to look at the sun is right at sunrise and sunset, because the sun has lost a lot of its light to refraction. It's a lot dimmer than usual, but even then you got to be careful, okay? And I'm just going to go ahead and say, from me, just never look at the sun. Just never look at the sun. That's my recommendation. Just look at pictures of the sun, okay? Do not take medical advice from me. No. Okay. Now, yeah, so if you have a hard time remembering what an annular solar eclipse is, just remember that annular means ring, okay? And so during an annular solar eclipse, it's a failed total eclipse where it looks like the sun liked the moon so much that it put a ring on it. Blah, 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 blah. Okay, now, here we go.